Hello students, this is the sixth part of relations. Today I am going to explain JEE model problem set 3 and 4. Before that, again I want to explain the definition of relation. For example, this is one set A, this is set B. X belongs to set A and Y belongs to set B. X is paired with Y under the relation R. Then here Y is called image of X with respect to the relation R. I will write Y equal to R of X. Notation important. Y is called image of X with respect to the relation R. Okay. Or X is called pre-image of Y or inverse image of Y. You can write X equal to R inverse of Y. X is called pre-image of Y or inverse image of Y with respect to the relation R. These two notations are very important. X is called image of X with respect to the relation R. Sorry, Y is called image of X with respect to relation R. Okay. And X is called image of Y, pre-image of Y with respect to relation R inverse. Okay. Let's see here. For example, A, B, C are three sets. X is in A, Y is in B, Z is in C. X is related to Y under the relation R. Then what you can say, Nana? Y is said to be the image of X with respect to the relation R. Means Y equal to R of X. Let it be equation 1. Okay. Now if Y is paired with Z with under new relation, say S. So what you call Nana Z here? Z is the image of Y with respect to the relation S. So what you can write is Z equal to S of Y, equation number 2. Observe students, Z is the image of X also, no, under new relation. We want to identify what is that new relation. The new relation is from A to C only. What is the new relation should write? What is the new relation from A to C? By using 1 and 2. Observe here. Take second one. Z equal to S of Y. Or Z equal, so instead of Y, what I can write from equation 1, R of X I can write. Observe student, Z is the image of X under this new relation. S R is a new relation. S bracket R. So what you can write is symbolically S circle R you can write. Z equal to S circle R of X. So what is the meaning of that? Z is the image of X with respect to new relation S circle R. So what is the meaning of that? S circle R is a relation from A to C. Okay. What is this means? I can write S circular. S circular is a relation from A to C. Okay. So last part I explained how to find a composite relation. Okay. So that is S circular. How you got S circular? Now I explained. Students, once again listen. R is from A to B relation. S is from B to C relation. If these two are same, then a new relation exists from A to C. That is S circle R. Should take care of that. Not R circle S, S circle R. S circle R is a new relation from A to C. That is called composite relation of R and S. Students. Now I want to explain problem. First problem, important problem, very important model. N is a set of natural numbers and R is a relation n cross n defined by R is a subset of n cross n. What is the relation? Ordered pair A comma B related to ordered C comma D if and only if A plus D equal B plus C. Ordered pair A comma B related to ordered pair C comma D means if and only if double implies A plus D equal to B plus C. So here important thing is if ordered pairs to LHS to RHS, how to write LHS to RHS? RHS to LHS is very important. LHS to RHS means, see, observe, first term, last term. A plus D equal to B plus C. For example, L comma P related to some x comma z is given. How to write means L plus Z, L plus Z, see L plus Z equal to P plus X, P plus X. Okay, LHS to RHS. If RHS to LHS, how to write that I will explain. L plus Z equal to P plus X means, yeah, L comma P, L comma P, first and third term, first and third, L comma P, L comma P related to, L comma P related to, okay, next last and second, that is X related, X comma Z. In this way, you can write LHS to RHS, RHS to LHS. So, according to the given relation. Now, we want to prove that this relation is an equivalence because I know that. So, first of all, I want to prove that this is reflexive, symmetric and transitive. So, just feel that ordered pair A comma B is X nana, ordered pair C comma D is Y. So, X related to Y given, to prove reflexive, X related to X should be true. To prove symmetric, X related to Y should be gives Y related to X. To prove transitive, X related to Y and Y related to Z gives X related to Z. Okay. So, one by one I will prove nana. First of all, reflexive. Reflexive. First one is reflexive. Reflexive. Yeah. Ordered pair A comma B related to ordered pair A comma B. We want to prove that this is true. X related to X only, no? Reflexive means ordered pair A comma B related to ordered pair A comma B. By using given relation, I want to write ordered pair A comma B related to C comma D means what is the meaning of that? A plus D, first term with the last. A plus B equal to, next what nana? Second term with the third term. Second term with the other. B plus C. Sir, B plus A. So, what is A plus B equal B plus A only, no? True only, no? Statement is true. Which is true? What is the meaning of that? R is reflexive. R is reflexive. Reflexive completed. Now, you want to check for, symmetric, nana. You need to check for symmetry. Okay. Okay. Ordered pair A comma B related to ordered pair C comma D. What should prove? Gives C comma D ordered pair related to A comma B. That is our plan. Okay, C comma D related to A comma B. Then you can say that it is a symmetry. Okay, students, equal to, yeah, what is that? A plus D equal to B plus C according to the given rule. Okay. Next, if A plus D equal B plus C means X equal Y means Y equal X only. No, I can say B plus C equal to A plus D and X plus Y equal to Y plus X only. Interchanging, no problem. Instead of B plus C, I can write C plus B equal to D plus E. C. Okay. C plus B equal to D plus A. Now, according to the rule, RHS to LHS, how to write RHS to LHS? So, first order pair is A comma B. A comma B means first to third element. First to third. C comma D, yeah, related to, yeah, C. Yeah. Next, what happened? C comma D, last to second. That is nothing but A comma B. So, what you got now? A comma B related to C comma D gives C comma D related to A comma B means R is symmetric. R is symmetric. R is symmetric. So, R is reflexive and R is symmetric. Now, I want to prove that R is also satisfies transitive. So, transitive checking is difficult, Nana. Observe with care. A comma B related to C comma D double implies A plus D equal to B plus C. C comma D related to E comma F gives, see how to write, C first with last means C plus F equal to, yeah, second with third D plus E, yeah. Now what should prove, Nana? A comma B related to C comma D, C comma D related to E comma F gives A comma B related to E comma F. A comma B related to E comma F you want. So what I am doing, I am adding these two equations. While adding, observe, Nana. Yeah, what happened? D get cancelled, C get cancelled. What will left, I will write A plus F equal to B plus C. Now by using this, you want to write ordered pairs. RHS to LHS give relation. First ordered pair is, C, A comma B, ordered pair A comma B. First and third A comma B related to last and second. Last and second means E comma F. Observe, students, what you got? A comma B related to C comma D, and C comma D related to E comma F gives A comma B related to E comma F. Means that R is transitive. Already R is transitive, symmetric, reflexive, and transit. So R is an equivalence relation. At last you should write. Therefore R is reflexive, symmetric, and transitive. So it is an equivalence relation. Okay, now our second problem, Nana. Here R is the real number line. Some two relations are given, S and T. We want to show that S and T are equivalence or not. See, all options are related to equivalence only. So you want to check whether S and R gives equivalence or not. One by one I want to check. First of all, I want to take set R relation S is given as x comma y such that y equal to x plus 1 for 0 less than x less than 2. What is the meaning of this, Nana? X related to y means y equal to x plus 1. So first of all, I want to check for reflexivity. So reflexive. What should prove? X related to x should be true. Okay. So x related to x implies x equal to x plus 1. So what is this? X get cancelled, no? 0 equal to 1. Oh, 0 equal to 1 never true, no? False. This is a false statement. What is the meaning of that? Reflexive fails. Reflexive fails means no need to check for remaining because all the options are related to equivalent. So given S relation is not equivalent. Therefore R not S. S is not equivalence. S is not equivalence. Not R, Nana. S should write. S is not equivalence relation. Okay. So see options. 2 is not correct. C, yes should write instead of R. Okay. 2 not correct. Automatically 3 is also not correct. So we have two options. One option and 4. One saying that neither S and T are equivalence. Fourth saying that T is equivalence and R is not. S is not equivalence. Okay. So now I want to check for equivalence for the relation T. So T is given as ordered pair x comma y such that x minus y is an integer. Yes, students, what are x and y here, Nana? X and y are real numbers. X minus y an integer. So reflexivity, checking for reflexivity or reflexive. X related to y implies x minus y is an integer. This is a given relation. Okay. Now checking for reflexivity or reflexive. X related to x should be true if it is reflexive. What the meaning of that? Implies x minus x is an integer. X minus x is an integer. X minus x 0. 0 is an integer. 0 integer only, no? Whatever me x 0 is integer only. If I take another half minus half also 0 only. 0 is an integer. True statement. The meaning of that? Given T is reflexive. Given relation is reflexive. Next for symmetric. Checking for symmetric. X related to y implies x minus y is an integer, x minus y an integer. X minus y an integer. So what should prove, Nana? X related to y gives y related to x. Okay, if minus 3 is integer, 3 is an integer, minus 3 also integer only. X minus y integer, minus of x minus y also integer only. Important, Nana. 3 integer, minus 3 also integer only. X minus y integer, minus of x minus y integer only. Open minus, what happened? Minus x plus y, or y minus x is an integer. So, x related to y means x minus y integer, y related to x means what is the meaning of that? Y related to x. What you got here? Y related to x. Here only I want, right? Y related to x. What is the meaning of this, Nana? X related to y gives y related to x. Means, yeah, T is symmetric. Okay. Now you want to check for transitive. Yeah. X related to y implies x minus y integer is an integer. Y related to z implies y minus z is an integer. Yeah, students, here important. Integer, another integer. Added also integer. Subtraction also integer only. So integer, another added, the addition also integer only. No, I want to add these two results. So what happened? Y get cancelled. X minus z, an integer. A new integer, x minus z. Y get cancelled. What will get? X minus z is an integer. So what is the meaning of that? X related to z. Means x related to y and y related to z gives x related to z. Therefore, T is transitive. Already T is reflexive, T is symmetric. Now you put that T is transitive. Therefore, T is an equivalence relation. So I can go with the fourth option. Okay, students. Our next problem. Third one. A equal to 1, 2, 3. B equal to 1, 4, 6, 9. And R is a relation from A to B defined by x is greater than y. X is such a way that I want to write R. Directly I want to write R. X is greater than y. So in ordered pair x comma y, your x should be greater than y. Such a way that you want to write ordered pairs. Okay. Yeah. 2 comma 1 I can write. 2 is greater than 1 only. No? 2 comma 1, 2 comma 6 I can't write, 2 comma 9 I can write, 3 comma 1, only 1 3 comma 1. Only 2 ordered pairs under the relation. X should be greater than y. No? A cross B you can find. A cross B containing 12 ordered pairs. From the 12 you can take 2 only. Those 2 are 2 comma 1, 3 comma 1 under the relation. So domain is 1 comma 3 and range is set 1 only. So I can say that my answer is 3. X greater than y. Under that relation only you can write the ordered pairs. Okay. Your x should be greater than y. You get 12 ordered pairs. Among 12 ordered pairs, you can choose 1 comma 1 you can't write, 1 comma 2 you can't write, 1 comma 3 you can't write, 2 comma 1 you can write. Like that, what I did, we got 2 ordered pairs, that is 2 comma 1 and 3 comma 1. So it is the range of the given relation is only singleton set, that is set 1. I want to move to fourth problem. Identity relation is dash. Already proved equivalence relation. Identity relation always equivalence relation. Already explained concept. Okay. Should remember that one. Yeah. Next fifth problem. The relation R is given on 1, 2, 3 is what type of relation? First of all, I want to write ordered pairs. 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, 2 comma 3, 1 comma 3. On which set? 1, 2, 3 set. So for example, reflexive 1 comma 1 should be, 2 comma 2 should be, 3 comma 3 should be. So that's why given relation is reflexive. Directly I can say reflexive. I want to write reflexive, symmetric, transit. Reflexive satisfied. Now only check 1 comma 1, 2 comma 2, 3 comma 2. Now checking for symmetric. 1 comma 1 it's reverse 1 comma 1, that one only. 2 comma 2 it's a 2 comma 2, that one only. 3 comma reverse that one only. 1 comma 2 reverse 2 comma 1, that is not there, no. 1 comma 2, 2 comma not there means what is that? It is not a symmetric relation. Given relation not symmetric relation. Now I want to check for transit. Interesting, Nana. Take first of all 1 comma 1. Take another order. Started with 1. Started with 1. Where is that? 1 comma 2. Okay, 1 comma 2. So 1 comma 1, 1 comma 2 gives 1 comma 1, 1 comma 2. Already 1 comma 2 is there. Okay. Next, try to use another order pair ending started with 1 comma 3. 1 comma 1, 1 comma 3 should be. 1 comma 3 is there. So with 1 comma 1 order pair checking completed. Now I want to take 2 comma 2 order pair. Now take another order pair started with 2, that is 2 comma 3. 2 comma 3. So 2 comma 3 is already is there. So 2 comma 3 with 2 comma 3 checking completed. Next 3 comma 3 you take. Take another order pair started with 3. So there are okay only one, that is 3 comma 3. 3 comma 3 no ordered pair, no need to check, no need to check. Yeah, so what happened, automatically given relation is transitive. 1 comma 3 and 3 comma 3, 1 comma 3 completed. What is the meaning of this? Transitive is satisfying. R is satisfying transitive. Reflexive and transitive. Reflexive but not symmetric. Reflexive and not transitive. Symmetric and transitive. Okay, I can move with the third option, symmetric and transitive. Okay. Sorry students, I will move with first option. Reflexive but not symmetric. Okay, that is correct. Reflexive but not symmetric. Next, A having 3 elements, B having 4 elements. How many relations exist from A to B, so that A and B having 2 common elements? So then N cross B having how many elements? 12 elements. A cross B containing how many subsets? Automatic 2 power 12 subsets. 2 power 12 subsets. All subsets are relations from A to B only, no? Just she asked how many relations exist from A to B, means I can say the 2 power 12 only, irrespective of those 2 common elements. So I can say that there exist 2 power 12 relations from A to B. Already you know the formula, 2 power n of A cross B relations exist from A to B. Next example. Next 7th problem. Yeah, 1, 2, 3 set is given, ordered by 2, 2, 3, 1 is given, 1, 3 also given. Now you want to check what type of relation is that. It is not reflexive, 1 comma 1 should be, 2 comma 2 should be, not there, not reflexive. Symmetric. Symmetric reverse, 2 comma 2 reverse 2 comma 2 only. 3 comma 1 reverse 1 comma 3 there. So it is symmetric. You are now checking for transitive. 2 comma 2, another order pair started with 2, not there, no need to check. Okay, 3 comma 1, another order started with 1, that is 1 comma 3 is there. So 3 comma 3 should be, 3 comma 3 not there. So it is not transitive. Means what is the meaning of that? Only symmetric relation. Okay. Yeah, students, next JEE model problem set 4. Yeah, first problem, A is given as x square minus 3x plus 2 equal 0. Just we want to solve for x, then we'll get set A. After that you can find A cross A, that is nothing but R. R is universal set, no? Actually universal relation is A cross A only. So R equal to A cross A. R equal to A cross A. Indirectly given R equal to, not subset, R equal to A cross A. R equal to A cross A. A cross A should find what we will get, that is nothing but R. First of all, I want to write the elements in A. That's why I want to solve for x square minus 3x plus 2 equal to 0. That is x equal to 2 comma 1. Obviously, you can factorize it now, x minus 2 and x minus 1 equal to 0 only. So having 2 elements, that is 1 comma 2. A cross A having 4 elements. What are that? Another 1 comma 2. 1 comma 1, 1 comma 2, 2 comma 1, 2 comma 2. 4 elements. The A cross A nothing but R now. Universal relation R. R is nothing but 1 comma 1, 1 comma 2, 2 comma 1, 2 comma 2. See, check options. Okay, fourth option is correct. Okay, so next problem. So interesting one. W denote the words in the English dictionary defined by the relation R. Okay, R equal to x comma y. Yeah, belongs to W cross W, such that x and y have at least one common letter. Interesting problem. Observation. X related to y implies x and y have or will have at least one common letter. Will have at least one common letter. Now you want to check what type of relation is this. Okay, first of all, I want to take reflexive, reflexive. Yeah, x related to x means what is the meaning of x and x will have at least one common letter. I will write do symbol for that. Meaning of that will have at least one common letter. X, x both are same letters, no, same words, no. All letters are common. Means what is that? At least one letter is true only. That's a reflexive satisfied. Symmetric. Next symmetric. Symmetric relation. Checking for symmetry. Okay, students. Yeah. X related to y should give y related to x. X related to y. What is the meaning of that? X and y will have at least one common letter. Okay, x and y will have one common letter. Automatically y and x also will have one common letter only, no? X word and y word have one common letter. Automatically y word and x word also have one common letter only. What is the meaning of that? So automatically I can write y and x also will have only one common letter. What is the meaning of that? Y related to x. So x related to y gives y related to x. Means R is symmetric. Now checking for transitive. Interesting, and transitive not easy. Yeah, transitive. Yeah, x related to y implies x and y will have one common element, letter. Y related to z implies y and z will have one common letter. Now through examples I will explain you. Actually you want to put that x and z will have one common letter, then you can say that is a transitive. I want to take x as AB or ABB, y as ACC. See, A common, no? X and y have one common letter, that is A. Or ACD you can take, that is not a big problem. Y is taken as ACD. So Z is I am taking as, observe students, D something, just DD. Now observe, no? X and y have one common letter. Y and Z have one common letter. But X and Z, observe X and Z, ABB and DDD, no common letters, no? No common letter, need not be common letter, but the meaning of that transitive fails. X related to y and y related to z does not give x related to z. Means given relation is not transitive, R is not transitive, only reflexive and symmetric. No, I want to check options. Symmetric, reflexive, symmetric and transitive. Okay, wrong that one. Okay, correct only, not trans. Okay, option 1 correct. Automatically single answer type question, no need to check for remaining. So finally what I got now, it is reflexive and symmetric, not transitive. Okay, next question, third question. R is the relation less than, observe now, less than means x less than y. Our first component should be less than the second, such a way that we want to write ordered pairs. So x related to y gives x less than y. This is the relation. Such a way that you want to write ordered pairs. From A to B. So what is A given? A given 1, 2, 3, 4, 5. And B is given as 1, 4. So A to B the relation, no? A to B the relation. Now I want to write ordered pair to satisfy x less than y. 1, 1 I can't take. 1, 2 I can take. Like that. 1, R I want, right? 1, 1 I can't take. 1, 2 I can take. Now observe, 1, 2 I can take. 1, 3 I can take. 3 not 2, 4. So 3, 1 I can take. 3, 4 I can take. 4, 1 I can take, 4, 4 also I can't take. 5, 1 I can't take, 5, 4 also I can't take. That means that, so completed. The only 3 ordered pairs. 1, 4, 2, 4 and 3, 4. So this is the relation R. So what do you want on inverse you want, R inverse you want, R inverse. Just to interchange x components and y components. 4, 1, 4, 2 and 4, 3. So this is R inverse. Check where is that in options. Okay, second option is correct. Okay, students, next problem, Nana. Fourth problem. Set has n elements. The number of relation defined on A means A cross A. A cross A should find. N of A cross A should find first of all. The relation is A cross A. N of A cross A. A having n elements, B having n elements means A cross B will have n into n square elements. Like that, A cross A will have 2 power n into n elements. That is 2 power n square elements. 2 power n square, yeah, relations exist from A to A. So this is interesting problem, students. A given relation R on A defined by two rules, not one rule. X less than y and mod of x square minus y square less than 9. Two rules are given. So this is not an easy problem. I want to write ordered pair satisfied by these two relations. First of all, I want to write set A. There is 1 comma 2 comma 3 comma 4 comma 5. Another A should write, that is also 1 comma 2 comma 3. That is A cross A gives 25 elements. 25, 5 into 25. From 25 you want to choose ordered pair which satisfied by these two conditions. First condition is x less than y condition. Next condition is mod of x square minus y square less than 9 condition. First of all, I will write the ordered pair which satisfies first condition, that is x less than y, Nana. After that I will write, I will cross check with the second option. Okay. 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5. So those satisfied by x less than y condition. 2 comma 3, 2 comma 4, 2 comma 5. 3 comma 4, 3 comma 5, 4 comma 5. That's all. These are ordered pairs satisfied by first condition, that is x less than y. Now you want to check the condition for mod of x square minus y square less than 9. Mod of 1 minus 2, 1 minus 4. Yeah, 1 minus 4 means that is minus 3. Mod of minus 3 is the correct only. So 1 comma 2 will satisfy. 1 minus 9, minus 8, mod 8 satisfies. 1 comma 4, 1 minus 16 with mod, yeah, won't satisfy. 15 less than 9, not true. So 1 comma 4 not so, 1 comma 5 will not satisfy. 2 comma 3, 4 minus 9 and 5 satisfies. 2 comma 4 minus 4, 16, 12 not satisfies. Yeah, 12 no, mod of 12. Yeah, not satisfied. 3 comma 4, 9 minus 16. 9 minus 16 means 7 will satisfy. 7 less than 9 only. So 3 comma 5 won't satisfy. 9 minus 25, 16, no, not satisfy. 4 comma 16 minus 25. So 16 minus 25 means what? 9. 9 less than 9, not satisfy. 9 less than 9. Are equal to not there, not satisfies. Means what are the remaining ordered pairs? Only 1, 2, 3 you have, 4. That is are equal to 1 comma 2. 1 comma 3, 2 comma 3, 3 comma 4. This is the relation R. Now identify where is that. Okay. So I can go with the fourth option. All ordered pairs are there. Fourth is correct.